Hello and welcome to the second video and the final video for the assignments over Thanksgiving week for multidimensional calculus. So this time we are going to talk about a concept called divergence. So when it comes to divergence, there is an interesting application that has some definite real-world effects for aerospace engineering. And by the way, mechanical engineers, aerospace engineering is pretty similar to you, and civil engineers, you design runways. One of the things you design is runways, so you should know about this as well. So when it comes to microbursts are an intense, sudden downburst of air, typically resulting from a thunderstorm, where an air column will go down and then immediately will disperse along the ground. So the deal is, with microbursts, you have something called divergence. So when it comes to divergence is the amount of fluid that moves away from a point. It is similar to flux in that we are measuring fluid moving towards or away from something. However, it is different than flux in that it is now based on a point and not a boundary curve. By the way, in terms of microbursts, the impacts on aviation are definite. If there are ever microbursts in an area, planes will not try to land. Pilots are trained to deal with an unexpected microburst. And in case you were wondering, yes, in the past there were crashes due to microbursts. One notable in Dallas, where an aircraft flew into a microburst close to, on final approach to Dallas-Fort Worth International Airport, landed short of the runway, spun out, and unfortunately, yes, there were fatalities in that. So now let's focus on the math and not go into a dark subject. So anyway, again, divergence is something that has definite engineering applications, and it is something in aerospace engineering that really needs to be understood, because the effects of divergent phenomena such as microbursts have a major effect on engineering design. So with that being said, let's talk about what divergence is and how to calculate divergence. Divergence is the amount of fluid that moves away from a point for a given vector field. If the divergence is zero, then an equal amount of fluid flows towards the point as away. If there's positive divergence, more fluid flows away. If there's negative divergence, more fluid flows towards. In case you were wondering, there is a phenomenon where you have negative divergence, and that is monsoonal rains in the desert. Warm air converges into a column, rises up, becomes liquid, and then forms thunderstorms. So again, divergence has another application in terms of weather. And I believe there are other applications involving fluids. However, sorry, that's not my specialty. And in case you're wondering about the weather applications, yes, I've done some atmospheric physics work as an undergrad. So now, to calculate divergence, all we do is we take the corresponding derivative of each component and add them. To be clear, divergence is a scalar quantity, meaning when we calculate divergence, the answer is a number. So if we have a vector field P, Q, R by component, the divergence is the derivative of P with respect to X plus the derivative of Q with respect to Y plus the derivative of R with respect to Z. Again, it is not a vector, it is a scalar. So there are no vector components in this. So let's calculate the divergence for two instances. One where we calculate the divergence in general of a vector field, and another where we calculate the divergence specifically at a point. So let's start out with calculating the divergence of the vector field. First component, 5x squared y. Second component, 2x y to the fourth minus z to the third y. Third component, 3zx plus z to the third y. So, calculating the divergence of this, we start out by taking the derivative of the first component with respect to x. So, the derivative of the first component, 5x squared y, with respect to x is 10xy. Next, we take the derivative of the second component with respect to y. So the derivative of 2x y to the fourth minus z to the third y. The derivative of 2x y to the fourth with respect to y is 8x y cubed. And the derivative of z to the third y with respect to y is just z to the third. So that's the derivatives of the first two components. Then we take the derivative of the third component with respect to z. So the derivative of 3zx with respect to z is 3x. The derivative of z to the third with respect to z is 3z squared. And the derivative of y with respect to z is just 0, so that can be left off. And right there, we have the divergence of f. That's all we have to do. So now, let's move on and calculate the divergence at a point. What this is going to involve is calculating the overall divergence of a vector field and then inserting the coordinates for the point. So, let's begin. So, to calculate the divergence of this vector field, we start out by taking the derivative with respect to x of this first component. So the derivative of e to the x cosine y with respect to x is e to the x cosine y, as the derivative of e to the x itself and cosine of y does not involve x. Next, we take the derivative of the second component with respect to y. The derivative of e to the x sine y is e to the x cosine y, as the derivative of sine is cosine and e to the x does not involve y. Then we add on the derivative of the third component with respect to z. The derivative of z to the third is 3z squared, and there we have the divergence of g. The next step is to plug in the coordinates of the point. Plugging in the components, we plug in 3 for x, pi over 3 for y, and 5 for z. This results in us getting the expression e to the third cosine of pi over 3 plus e to the third cosine of pi over 3 plus 3 times 5 squared. Using trigonometry to calculate cosine of pi over 3, cosine of pi over 3 is 1 over 2. So we have 1 over 2 e to the third plus 1 over 2 e to the third plus 75, which results in a final answer of e to the third plus 75. This concludes the video on calculating divergence. I hope you all have a nice week off. For those of you watching before Thanksgiving, have a happy Thanksgiving, and I will see all of you next week. Thank you for watching. Bye.